In this simple picture, we can see the basic operations of the one-resource mapping module to solve the optimal placement of the service graph virtual machine on the available VIMs, taking into account the available metrics. Here we can see the delay constraints applied to the access point and to the different node links in order to drive the decisions. Here we can see the different components developed by Ericsson, whose demonstration will be shown in the following part of this video starting top-down from the E&M GUI. The GUI provides an effective way to visualize and showcase the one-resource mapping capabilities, and also to execute commands in standalone demonstrations. Otherwise, commands are received from the OSS of the Matilda framework in fully integrated demonstrations. Inside the one-resource mapping, the core part is constituted by the path computation engine, which performs the required elaboration starting from the network topology, and whose outcomes are applied to the network by the wide area routing setup on the left side, that acts directly on the OpenFlow switches used in the demo. During the following demo, the switches are emulated with Mininet. At this point, we can start running the demo. First of all, we launch the Mininet configuration to create 6 switches and 2 hosts. We can already verify that host 1 is not able to ping host 2. In fact, we can see that the ping is not working. Now we start the path computation engine. Just a few seconds. We run the proxy path for handling all the REST requests. And then the interface path toward the browser. Now we can connect to the browser and verify our topology. In this case, the used topology is characterized by 6 switches, 2 VIMs, and 2 access points. The different links are associated to a certain delay that is shown when passing over them with our mouse pointer. Now we can show the request of a slice creation. We have created some templates that summarize the list of the parameters that are received in the request command, and that indicate which constraints have to be applied to the virtual machine placement inside the VIM. Constraints can be hard or soft according to their blocking property, in the case that some of them would not be satisfiable. We send a request to the path computation engine and we receive a set of solutions ordered according to the overall delay, starting from the optimal solution. In fact, we can verify the first solution delay and the final one. In the different choices, we can read the different requested placements. Now, if we select one of the slices, we can activate it. Until now, it was simply reserved. We can show the activation step, starting with the name and then specifying the maximum bandwidth associated to the flow that will be created for the required slice. After this activation step, we can verify that all the OpenFlow switches have been correctly configured, and host 1 can effectively reach host 2. We can see the ping command working. With the GUI, it is possible to see the details of the executed placement. In particular, selecting the slice, we can visualize in red the links used for the path instantiation, and then we can visualize the access points and the links that connect the virtual machine inside the slice. We can expand to further detail levels and select a particular connection. We can visualize the details of the requested routing. As we can see, the physical links are highlighted in bold red and the virtual links interconnecting the different virtual machines in green. We can show the request of a second slice. In this case, we can select the worst one to show a more complex scenario. We activate also the second one. OK. In the same way, we can show how the different virtual machines are placed with all the relative interconnections. And this concludes our demonstration. Thank you for your attention.